Then enthalpy change of atomization and electron affinity. Now atomization is basically the production of atoms or conversion to gaseous atoms, right? So let's see the definition. The standard enthalpy change of atomization, delta H standard symbol AT, is the enthalpy change when 1 mole of gaseous atoms is formed from its element under standard conditions, right? So now when you take lithium, it is under standard conditions, it is solid. So conversion of lithium solid atoms into 1 mole of lithium gas. So that is what we are talking about. So here it is plus 161. So that means energy has been taken in. It's an endothermic reaction. Then chlorine, it is half Cl2 becoming Cl gas. Once again, there has both are in the same state, gaseous state, but half of a chlorine molecule is what becomes chlorine, 1 mole of chlorine atoms. Another important thing that you need to understand here, value of delta H AT are always positive, means always endothermic. Like lattice energy is always exothermic, here delta H atomization, they are always positive and they are endothermic, because energy must be supplied to break the bonds, right? So there are different kinds of bonds that exist between these atoms. To break them, you need to provide energy. Right, please pause the video and go to question number 2. Do it and come back. I will be discussing the answers in this video itself. I hope you did the question. So let's go to the second question. Part A. The bond energy of the chlorine molecule is plus 244 kilojoules per mole. Why is the standard enthalpy change of atomization half its value? The reason is, when the bond energy means chlorine gas molecule, that is Cl2 turning into 2 chlorine atoms, 2Cl atoms. But here that is Cl2 gas, right, the molecule turning into 2Cl atoms in gaseous state. That is what we refer to as the bond energy of chlorine. But here we are getting 2 chlorines. But in standard enthalpy change of atomization, okay, delta H AT, what do we speak about? What are we talking about? In delta H atomization, we are talking about 1 mole of, it is 1 mole of gaseous atoms, 1 mole of gaseous atoms, but here we have 2 moles of gaseous atoms. So because of that, we have to take half of its value. So the enthalpy change of atomization is plus 244 divided by 2, it is plus 122. Right. Then part B, write the equations including state symbols that represent the enthalpy change of atomization of oxygen. Right. So oxygen, once again, it's a biatomic molecule, so it has to be halved. That means half of O2 gas turning into what? O gas. That is what that is the atomization for oxygen. Then barium, right? Barium is a solid. It has to turn into barium gas. Simple. Then bromine, once again a diatomic molecule, biatomic molecule. Half Br2 gas turning into Br gas. I hope that made sense. Right. Then let's move to electron affinity. Electron affinity, once again there is a definition. But this electron affinity is something that you have to be very concerned about, because electron affinity has different definitions depending on which electron affinity we are talking about. Basically the energy change which occurs when a gaseous non-metal atom accepts one electron. Why do we say non-metal? Because metal ions do not accept electrons. Here it is becoming negative. Accept one electron is called electron affinity, right? Ea. The first electron affinity, Ea1, is the enthalpy change when 1 mole of electrons is added to 1 mole of gaseous atoms to form 1 mole of gaseous minus 1 ions under standard conditions. Right? So each of those parts are important. 1 mole of electrons is added to 1 mole of gaseous atoms to produce 1 mole of gaseous minus 1 ions. Right? So now chlorine gas, if you take chlorine gas, Clg plus E gives Cl minus gas. And as you can see, there is a negative sign here. Right? Then sulfur, it doesn't stop there. Remember that sulfur has a second electron affinity as well. Why? Because its charge is S2 minus. So here it is becoming only S minus 1. Why? Because we are only adding, the first electron affinity refers to adding only one electron to the atom, right? So it is again minus 200. The change is from gaseous atoms to gaseous negative 1 ions. The enthalpy change for the first electron affinity is generally exothermic, but there can be exceptions, right? Generally it is exothermic. If there is if it goes on to the next one, then you can get Ea2, Ea3, etc. Why? Because we are adding more electrons. Then let's go for the second electron affinity definition. Perhaps you might want to say that. Well, I hope you know the definition of that. The second electron affinity is the enthalpy change when 1 mole of electrons is added to 1 mole of gaseous 1 minus ions to form 1 mole of gaseous 2 minus ions under standard conditions. Right? So from 1 mole of minus 1 ions to 1 mole of 2 minus ions is being produced. And third electron affinity is then producing 1 mole of addition of 1 mole of electrons to 1 mole of gaseous 2 minus ions to produce 1 mole of gaseous minus 3 ions under standard conditions, right? So on and so forth. Right. So then the equations representing the first and second electron affinities of oxygen has been given here. First electron affinity is Og plus E minus giving O minus G. Right? Then second electron affinities, we start with O minus. Add an electron, it produces O2 minus. Second electron affinities are always endothermic. That is another thing that you must understand. And third and fourth, they are also the same. The overall enthalpy changing forming an oxide ion is taken now here because there are two enthalpies here. Minus 141 and plus 798, you get the sum of them to get the final enthalpy change. Then it would be plus 657 kilojoules per mole. I hope you understood these things. If you did understand them, please do question number 3. I'm going to do it here. Please pause the video and do the questions and then come back again. I hope you did the questions. So let's do question number 3. Suggest why the second and third electron affinities are always endothermic. Can you, what is your answer? You probably must have given a good answer. But let's hope, let's see whether your answer is correct. So they are asking, why is second and the third electron affinities are always endothermic? So now we are looking at addition of electrons. So these electrons are building up a negative charge. So more and more electrons are getting added. They are of the same charge. So what happens? Their charges will start to repel each other. When they start repelling each other, you have to overcome that repulsion charges. So to overcome the repulsion charges, you need more and more energy. So that is that repulsion is what makes what increases the energy requirement inside the compound. When electrons are getting added, to overcome the repulsive forces between electrons and the negative ion, we have to produce more energy, we have to supply energy, right? Then part B, the first electron affinity of sulfur is minus 200 kilojoules per mole. The second electron affinity of sulfur is plus 640 kilojoules per mole. Calculate the value for the enthalpy change S2 minus S2 S gaseous, combining with two electrons to produce S2 minus. So obviously you have to add them together. So that is going to be plus 440 kilojoules per mole. I hope you understood that, because the first electron affinity and the second electron affinity, you get the values and you add them. Minus 200 plus 640 is plus 440 kilojoules per mole, right? Then write the equations representing the first electron affinity of iodine. The first electron affinity of iodine. So that means first electron affinity means we are starting with I gas, no charge. Then you add an electron to produce I minus gas. I minus gas. Then the second electron affinity of sulfur. Now we have to be very careful. We are starting with not sulfur gas, but we are starting with sulfur minus gas. Plus electron giving S2 minus gas. I hope you understood that part. However, it seems like that I have missed to answer second question part C. What is the numerical value of the enthalpy change of atomization of helium? Explain your answer. Now, numerical value of the enthalpy change of atomization of helium. So what is the definition for atomization? The definition for atomization is the enthalpy change when 1 mole of gaseous atoms is formed from its element under standard conditions. Now, what is special about helium? Helium is already in its gaseous form. It is already in gaseous form. So we don't have to worry about it. So the answer is 0. Answer is 0.